Our planet is an absolute powerhouse. Seriously. From the incredible force of our rivers to the crazy heat boiling up from its core, there are these fundamental forces at work all around us, all the time. So today, we're going to explore how a little bit of human ingenuity can actually tap into these forces to, well, reshape our world. Yeah, just think about that for a second. It's a question that kind of forces you to look at the world differently, right? Not just as a place we live, but as this massive, incredible engine, just full of untapped potential. So let's start with the one we can all see pretty clearly, the power of water. If you've ever seen a gigantic dam, something like the Hoover Dam, you've witnessed its power firsthand. It's just an amazing feat of engineering, right? It's designed to take all the force of a river and turn it into something we can use every single day. But how does it actually work? What's the secret? Well, it all boils down to one core concept from physics class: potential energy. The easiest way to think about it is like a stretched rubber band. All that water held way up high in a reservoir, it's just packed with stored energy. And the second it's released, that potential energy instantly converts into kinetic energy, spinning massive turbines to generate electricity. Simple as that. But, and this is a big but, there are major trade-offs. While hydropower is a clean, renewable source of energy, the impact of building these things can be huge. I mean, a massive dam can permanently change a river's ecosystem, mess with fish migration, and even force whole communities to move. It's really a classic engineering dilemma. How do you balance this immense benefit against a really significant impact? Okay, so let's shift gears. We're going to move from the surface of the Earth to deep, deep within it. While rivers give us energy from falling water, the planet itself serves up another incredibly powerful source: its own internal heat. The idea behind geothermal energy is, honestly, brilliantly simple. We drill down, sometimes miles, to tap into superheated water and steam that's trapped in the Earth's crust. Then that steam gets piped to the surface where it does the exact same job as the falling water in a dam. It spins a turbine to generate electricity. And yep, just like hydropower, geothermal has its own list of pros and cons. Its biggest advantage, for sure, is reliability. It can run 24/7, doesn't matter if it's sunny, windy, or anything else. The plants also don't take up a lot of space. The catch? Well, you can only build them in very specific, geologically active places, like Iceland or parts of California. And, drilling deep into the Earth's crust always comes with its own set of risks. So let's just put these two side by side for a second. Hydropower, it's all about harnessing the potential energy of water, but it needs a massive footprint for those dams and reservoirs. Geothermal, on the other hand, taps into the Earth's internal heat with a much smaller plant. And that difference in their source leads right to that key distinction in reliability. Geothermal is just incredibly consistent. Ultimately, both of these amazing technologies are perfect examples of this core engineering principle. It doesn't matter if it's potential energy from water or thermal energy from the Earth's core, the goal is exactly the same: convert one form of energy into electrical energy that can power our lives. But, generating electricity is only one part of water's power. It's incredible, absolutely, but there's another kind of power it holds, one that is so much more fundamental to our actual survival. Let's just pause on that for a moment. Forget electricity, forget industry. What is water's most critical power? It's the power to sustain life itself. And for billions, literally billions of people, just getting access to clean, safe drinking water is a massive daily challenge. So this shifts our whole focus from harnessing water for electricity to the engineering challenge of simply making it safe enough to drink. And the threats are everywhere. Our water sources are under assault from all sides. We're talking industrial chemicals, agricultural runoff from farms, raw sewage, and all the plastic that's now choking our rivers and oceans. It's a huge problem. This right here, this frames the ultimate engineering challenge of our time. How do we use our ingenuity not just to generate power, but to clean up our own mess? It's like we're in a technological race to reduce our impact and restore the health of our planet's most vital resource. So how can it be done? Well, here's a pretty basic blueprint. It's a multi-stage process, right? First, you start by filtering out all the big stuff: leaves, trash, plastics. Then you move to finer filters to get rid of things like sand and silt. And finally, you get to the purification stage, and that's where you tackle the invisible threats, the bacteria and the chemical pollutants. And this brings us right back to the final question, a question for you. You've seen the principles of energy conversion, you've seen the logic behind water filtration. So how could you put all that into practice? How would you design, build, and refine a simple solution to one of the world's most pressing problems? Now that is the ultimate engineering challenge.